Today, let's go over a Leetcode hard question that I just solved by myself, which really surprised me, but it just shows the power of some of these inbuilt tools in Python. So I'm going to go ahead and go over it with you. As you can see, I kept getting time limit exceeded for a long time until I tried something different. So you're given an integer array nums, and what you want to do is return for each position how many numbers are smaller than the current. So here 2 and 1 are smaller than the current, so you return 2. Here 1 is smaller, so you return 1. Here only 1 is smaller, so 1. And then the last one, obviously 0, because there are no numbers to the right of nums, of the last number in nums. As you can see, there's always a 0 at the end. So I'm going to show you my own trick for doing this, which is pretty cool. There's a sorted list in Python for doing this. And what we want to do is start here. So nums of I plus 1 to the end. And then now we can iterate over nums. And what we want to do is, so actually the whole thing, and then we're going to remove the first element because this is already sorted, right? So we already have all that. So cur.remove nums of I. And then what we're going to do, so right now, we have, 1, 2, 5, 6, and then we're going to remove 5. So then now we're just going to have 1, 2, 6, and then we're going to remove 2, and now we're going to have 1, 6. Oops. And then after that, obviously you just have, well, you're going to remove 6, and now you just have 1, right? Which there's nothing to the right, it's just 0, right? So if you know this, that's how powerful the sorted list is. It's really saved me on this question. Then you can just do a bisect left inside of current, and then also seeing where nums of I goes, right? So 5 here, it goes 0, 1, 2. It goes in the second index because that's the pivot point where it's bigger than the previous element, but also smaller than the current element. So we're going to print B, 2, 2, 1, 0, 0, 0, 0. So now you can just append B to result, and then at the end you can just return the result. So this avoids having to do O of n squared, which is really helpful in this scenario. And as you can see, it's not the most efficient, but it is my own solution, and it passes all the test cases without getting time limit exceeded. Again, the bisect left will just take your current element, which is going to be like 2, for example, here, and it's going to give you 1 because it's supposed to be at index 1. It's less than or equal to 2, and that's the pivot point where it's not bigger than this current element anymore, right? So very, very powerful. And you can also do bisect right in Python, but I just wanted to show you how easy this question is if you know certain tools that you can use. So thank you for watching, and consider subscribing if you found this helpful, and please stay tuned for more.